Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Farhan Hakimi bin Abdullah, and today I will present about Fluid Lab 2, which is flow over immersed body. So for the introduction is, when a fluid flows over a stationary surface such as a flat plate, the wall of a pipe, the fluid touching the surface is brought to the rest by shear stress at the wall. The boundary layer is the region where the flow adjusts from zero velocity at the wall to maximum velocity in the mainstream of the flow. The concept of boundary layer is important in all aspects of viscous fluid dynamics and heat transfer theory. For the objective is, number one is to determine the flat plate velocity distribution. Number two is to investigate the relationship between flow velocity and the different immersed object shape. And number three is to estimate the drag force exerted on the immersed objects of different shape at different velocities. And for the scope for this experiment is, for this study, the consideration is to flow past or around immersed bodies. The scope of this study are as follow. One is to measure velocity and the height of the water that occur when the water is flowing past the immersed object. And number two is to estimate the drag force at the different flow velocities.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman Hakim bin Nawawi, ID MA 19032. Today I will be explain about the theory. When a fluid flow through an object, the object will experience resistance force that prevent the object from moving to its direction. The resistance force is called drag force. The resistance force or the drag force remain the same whether the body move through the fluid or the fluid flow around the object. As the relative motion remain the same, if the object with an angle flowing through the fluid, the resultant force won't be only drag force alone. It consists of horizontal and vertical forces. While the horizontal forces is drag force, the vertical force is the lift force, which is perpendicular to the flow of direction. Figure below show the resultant forces of drag force and lift force. The wake region, which is the stagnation pressure, is bigger compared to zero angle of attack. The dividing streamline and the stagnation point move down, hence the air flow above both the wing, and thus there is decrease in velocity below the aerofoil. In Bernoulli theorem, when decrease in velocity, pressure will increase. Therefore, the pressure below the aerofoil is higher than the pressure above the aerofoil. The lift force is generated in this way. We can calculate it by using the formula on the slide, which is drag force over dynamic head times by the area. As the flow in a dark, flow in a boundary layer may be laminar or turbulent. There is no unit value of the Reynolds number at which transition from laminar to turbulent flow occurs in boundary layer. Among the factors that affect boundary layer transition are pressure gradient, surface roughness, heat transfer, body forces, and free stream disturbance. In many real flow situations, a boundary layer develops over a long essential flat surface. A qualitative picture of boundary layers grow over a flat plate is shown in figure below. There is three types of the flow regime, which is laminar. The Reynolds number is below 2000, and for transition, the Reynolds number is within 2000 to 3500, and for the turbulent is Reynolds number is above 3500.
I will continue the presentation with the third chapter, which is the method and procedure in the investigation of flow pattern over immersed bodies and boundary layer. Let's go through it one by one together. The apparatus as shown in the slide consists of the following components: a mobile frame with bench top, radial fan with a power capacity of 0.55 kW, switchboard and drawer for small parts, an air intake pipe complete with throttle valve, thermometer, a rectifier, a removable nozzle or effuser, a funnel for an air inlet, an off-air pipe, a fixture for full water pressure gauge, and last is the measuring gland for measuring tubes. As my colleague explained earlier, this investigation consists of two experiments. The first experiment is the flow pattern of symmetric aerofoil at a different angle of attack, also known as the flow over immersed body experiment. The process begins with the experiment setup is depicted as in figure. The aerofoil model is fastened to the airflow bench with screw. To begin with the experiment, angle attack 0 degree is chosen as the initial angle attack. The switch is flipped on and the radial fan is free to travel around. The starting speed of the radial fan speed controller is set at 12. The result is tallied and reported. To observe the flow of T, air in the aerofoil, the smoke controller is pressed to emit smoke into the flow. The pressure of the aerofoil flow is captured. The radial fan speed controller is then adjusted by till the fan speed reaches 19. The experiment is repeated at 30 degree and 45 degree angles of attack. Moving into the second experiment, which is the flow over flat plate experiment, also known as boundary layer experiment. The technique includes the following steps. The experiment setup is depicted as in the figure. The smooth surface plate is inserted into the airflow bench. The initial distance is set to 0 and the distance after that is measured. The vernier caliper is linked to the pitot tube. As the initial data, the pitot tube is touched to the surface of the flat plate. The radial fan is then activated and any data collected and tabulated. The plate distance is raised by 20 millimeter to 140 millimeter, while the pitot tube distance from the surface of the flat plate is increased by 4 millimeter to 32 millimeter. Then the procedure is repeated for the rough surface. That's a little bit from me. I will pass the stage to my colleague in order to further this presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazi and I will present the chapter 4, which is result and discussion. So first, calculated velocity. So we use formula V equals to square root 2GH. So the table show the data, and then calculated drag force with formula CD equals to drag force over dynamic head times by area, and the table show the data for the calculated drag force. And then calculated lift force, the formula is CL equals to lift force over dynamic head times by area. This is the sketch of the streamlines of the airfoil, which is with 0 angle, 35 and 40 degree angle. So experiment 2A, smooth surface flat plate. The initial heat given is 274 mm. Calculated velocity, formula same, V equals to 2GH. So this is the data, we got the data for the calculated velocity, and then calculated Reynolds number. So next, experiment 2B with round surface flat plate. The initial heat given 274 mm. So the recorded heat is in the table. So first, calculated velocity, we use formula V equals to 2GH, and then the Reynolds number. For graph, velocity and Reynolds number versus boundary layer. So this is the heat, which is for both smooth and rough surface. This is the velocity graph, which is the blue line is the smooth surface and the orange line is the rough surface. And then this is the Reynolds number graph. So the graph velocity versus distance. So this is the boundary layer thickness given is 10.1 175 millimeter, and then this is the graph. Discussion. First question, which body creates the smoothest streamlines? The answer is body that creates the smoothest streamline is at zero angle because the flow channel is relatively small, the fluid is moving slowly, and its viscosity is relatively high. Second question, what does a smooth streamline portray? Laminar flow refers to the smooth, regular airflow patterns that surround an item and indicate the least amount of disruption of the air caused by the object's travel through it. The third question is what happened to the wing profile at 30-degree angle compared to the normal? The separation point jumped forward and it reached the maximum lift. Number 4, what phenomenon caused the orifice flow to disperse from your knowledge? By the Venturi effect, because of the reduction in fluid pressure that results when a fluid flows through a constricted section or choke of a pipe. For the conclusion, the experiment in the end went off without a hitch. The purpose of the experiment was to determine the bore thickness of a plate that had been exposed to a force. In experiment 1, the fan speed numbers are varied. We employ 8 distinct fan speeds for each angle, which is 0, 30, and 45 degrees. According to the statistic, as the fan speed rises, so does the force and velocity. When the fan speed remains constant, the angle utilized as well as the force rises. Rough and smooth surface were used in the second experiment. The height and velocity grow as the thickness of both boundary layers rises. In addition, the Reynolds number is increasing. Thank you.